Hello, everybody. This is Coach Raza again. So what I'm going to go in this video is that we're going to go ahead and do like a little quick review over like the 9-1, hopefully, and we'll see what we can refresh from there because it deals with area, and that's also part of the unit. So in this case, we have area of a triangle. We got area of parallelograms. We also have squares. But what I just want to focus on are rhombi and kites today, and along with the triangles. So I'll see if I can go ahead and knock them out. And so do a little quick refresher for y'all. Okay. So initially, if we have a rhombus that we're trying to look for, we're initially just going to go ahead and use the formula areas equal to 1/2 d1 times d2. Now, d1 and d2, all they are is that they represent a diagonal that goes from corner to corner. Kind of like and then vice versa. So this could be d1, and then if I have another one, I can go ahead and just make it go from there, and that'll be considered d2. So in this case, if I'm looking for d1, I don't know what it is because I have no idea what's in here. So if I'm trying to figure out what d2 is, I can figure it out because this is 21 right here, and that makes this one also be 21. So my total length for that one would be 42. So I have 42 meters is going to be for D2. Now the issue comes into play is that if I'm trying to look for the diagonal for one, I don't know what it is. So one way we can go ahead and go about it is that we can go ahead and break this down to where we're looking for this triangle. Now for this triangle is that what we're going to focus on is that we're going to go ahead and just break it apart for a little bit. And so this one part will be 21, this will be 35, and then this will be x. And then it comes back to becoming a Pythagorean theorem problem. So you're going to have to go ahead and use your, you're going to have to go ahead and use your a squared plus b squared to go ahead and solve this. So as we're going, let's see. So I have a squared plus b squared equals c squared. If I try and solve it, then I have 35 squared, 21 squared, and then I have x squared. Because remember, c is always the line that never touches the box. And so a and b doesn't matter. So if I go ahead and square this, I'm going to use my calculator for this. And let's see, I got 21 squared, which is 441. And then I have 35 squared, which is 1225. Okay, so you can go ahead and subtract 441 both sides. And then you do the little square root. 784. And so you got 784. Square root it. X equals to 28. Okay. So that means this part here will be our 28. So you have to use a Pythagorean theorem. There's no way around this. If you're looking for a side, this triangle helps out a whole lot. So you have 28. And then what's down here then? That'll be also 28. So which means it'll be 28 plus 28, which would be equal to 56. Okay, so this is 56 here. Now you can go ahead and solve for everything else that you need. So let's go look for area then. So area is equal to 1/2 d1, which is 56, d2, which is 42. You can go ahead and take half of 56, which is 28, times 42. And then 28 times 42. And the area would go ahead and be 1176 meters squared. Okay, so 1176 meters squared. So that's going to go ahead and be my area for this one. Now, the easy one is going to go ahead and be the perimeter, because if we're looking for perimeter, that's 35. This is 35. That's 35. That's 35, because they all have the same tick marks. So for perimeter, it will be 35 plus 35 plus 35 plus 35. So P is equal to 140. 140 years for that one. Okay, so that's going to go ahead and be your rhombus example. Okay, guys? So there you go. Oh, don't forget your units as well.